Welcome to another exciting moment. Today we're going to be talking about stoichiometrics. Now we're going to be looking at mole to mass and mass to volume. So here, before we go ahead, we have to know what stoichiometry is all about. Stoichiometrics is the study of the quantitative relationship which exists between reactants and the product in a chemical reaction. That is to say, when we talk about quantity, talking about the quantity of substances, quantity of the matters, substances that are going through chemical reaction. Sometimes this stoichiometry can also be used to, describe or explain the reaction that has to do with mass volume relationship in a chemical reaction. That is, most times we call it mass volume relationship. This is because um, most reaction can be in mass, some of them can be in volume. For example, displacement reaction that involve liberation of um, hydrogen, perhaps by zinc metal reacting with an acid, liberating hydrogen. That's a good example of um, reaction that involve mass and what volume. Hydrogen is coming out in volume, while the mass is that of the zinc. Zinc is measured in mass, taking the mass, a certain mass of zinc, and then you get into chemical reaction with an acid, liberating hydrogen. So in some other cases, there are some cases where volumes can go into reactions, like a case where we have carbon 2 reacting um, with oxygen to give us another this thing, to give us another gas, which is carbon 4. This is a good example of volume to volume. This is volume. The reactant is what? Volume, and the product is also volume. So this other one is another type of feed. There's so many of it. This time today we'll be looking at that mole towards volume. That is when you have something in mole, you are given the mole concentration of a substance. You are now asked to convert it to get what you have in volume or in mass. Now we will quickly go into that. Now, because before we go into this, we should be looking at, in stoichiometry. In stoichiometry, now in this ionic equation reaction, this is tetrasulfur acid ionizing to give us hydrogen ion and tetrasulfur ion. So we notice that 1 mole of this and give us 2 mole of hydrogen ion and 1 mole of tetrasulfur ion. In this thing we have here is what we call, sometimes we call it stoichiometric ratio of the reaction. This is what we call, I said what we call stoichiometric ratio of the reaction. This stoichiometric ratio of the reaction can also be equated to the mole, the number of moles that involve in a reaction. Now, because we know that molar mass of every substance is what? Is 1 mole, is a mass of 1 mole of that substance expressed in grams. And then you know that the unit is what? Mass, gram per mole. Now from there we can also we'll be able to get the reacting masses. You know that um, number of moles is always mass over what? Molar mass. That will give us the number of moles. So which simply means that to get the mass, the reacting masses will give us the reacting masses. The reacting masses in this case will then be equal to moles times molar mass. We can also get it from there. Now, in some cases, reactants can be in form of ions, atoms, or molecules. But now let's quickly look at a question that will help us, another chemical equation that can help us get this thing done. For example, like I stated earlier on, said a reaction between zinc ion this reaction is a reaction between zinc and tetrasulfate hydrochloric acid. Now, in this reaction, we have 1 mole of zinc, 2 mole of hydrochloric acid, and giving us 1 mole of zinc and 1 mole of hydrogen gas. So, in this place, you notice that we have mass. Um, this is the volume. In volume, this one is in mass, and then so now let's quickly look at this. This is their stoichiometric ratio. In this stoichiometric ratio, like I said earlier on, we can be used to address the mole. Now, from that mole, we know that mass to get we know the molar mass of this. Let's just quickly do that. Of molar mass of um, zinc there is what is say 65. So the reacting mass in this to get the reacting mass of this simply means that 1 mole times what this that will give us the reacting mass, the mass that reacted, like from what we have done. So in the same way, we can still do the same to get the masses that reacted here. So, but now we are going to look at some questions, some example questions that will help us really understand this very well. So, and I want you, if you have any question, please uh, don't hesitate to drop it as a comment there so that I can always address your questions. So let's quickly look at some calculations that can help us. This question says, how many mass of calcium chloride will be produced if 0.4 moles of calcium troxocarbonate reacts with excess hydrochloric acid? Now, to do this, the first thing you will do is that you get a balanced chemical equation, because from a balanced chemical equation, you will be able to know the relationship, the stoichiometric relationship that exists between them, between the reactant and the product. This is what you expected to produce. This is the product now, and this is the reactants. The two of them are the reactants. So what are we going to do now is to get a balanced chemical equation, because from that balanced chemical equation, you will be able to get this thing done. That is why it's important for you to learn how to balance a chemical equation, to understand chemical equation and be able to read out what you have in a chemical equation. Now, let's look at the balanced chemical equation. We have the chemical equation to be this. All right. Now is balanced. The equation is balanced now. From this chemical equation, the stoichiometric ratio of this uh, balanced chemical equation is telling us that 1 mole of the triazocarbonate will give us 1 mole of calcium calcium chloride. So, but now we are looking for the mass. We are looking for the mass. Because we are looking for the mass, we can then consider it in terms of mass. We get the molar mass of this. So it means that for this you have calcium to be 40 plus um, chlorine, which is that will be 2 brackets. Everything will give us in 11111. That is from this balance equation is telling us that 1 mole of calcium triazocarbonate will liberate 1 grams of what? Calcium chloride. That is what it means. So in that case, if it's so, what we want for 0.4 mole give us? So what it means that It means that one mole, one mole of calcium troxocarbonate will give us 1 grams of what? Calcium chloride. So 0.4 mole of calcium trioxocarbonate will then give us 1 over 1 times 0.4. That will give us that will give us that will give us 4.4 grams of calcium triosocarbonate. You can see how easy it is. It's not going to be, chemistry calculation is not a scary movie. Do you understand? It's something that is very simple, and when anytime you look at it, don't get scared. Don't get scared, especially in stoichiometry. Try to balance the chemical equation so that you'll be able to get this enough. Now let's quickly go to another one. This calculation now has to do with what? Mole towards mass. Let's try another question that has to do with what? Um, Mole towards volume. In this case, we are calculating the volume. It says that calculate the volume of carbon 4 liberated when 0.6 gram, 0.66 mole of calcium hydrogen triosocarbonate is decomposed by heating. Now, the next thing we'll also do, like I said earlier on, before you will be able to do this, note you should also know how to balance the chemical to get a balanced chemical equation. Now, the balanced chemical equation, since it's decomposition, we have calcium hydrogen triosocarbonate decomposing to give us calcium oxide plus, then we get um, so this is what it's like. So since it's like this, you notice that 1 mole, the stoichiometric relationship here is 1 mole, and 1 mole. But what we are interested in is the two. We're interested in these two. What is simply telling us from this balanced chemical equation is that 1 mole of this calcium hydrogen triosocarbonate will liberate 1 mole of carbon 4. So in that case, what it means here is that we going by that, we know that molar volume of every gas at STP is what? 22.4 dm cube. 23.4 dm cube. So what it means is that 1 mole of calcium will give us 22.4 dm cube of what? Carbon 4. So now 0.6 mole 0.6 mole will then be equal to 2.4 times 0.6. That will give us 26.88 dm cube, or we can also say 2688 cm cube. That is when you multiply by, if you multiply by 1000, excuse me, if you multiply by 1000, you get it to be what? 26880 cm cube. So this is just a simple way of getting through this kind of calculation whenever it has to do with mole and what? Volume, mole and mass. So you can see how we are able to do that. Now the most important, like I said earlier on, I would need to repeat it over and over, is a balanced chemical equation, ability to understand a balanced equation and get the stoichiometric relationship there. So I thank you so much for being part of this. I would like to read your comment. If you have anything you think you can ask us, any comment you want to make, you can always leave it at in the comment section. And again, um, I want you to like, and if you have not subscribed, just do well. That's one of the ways of encouraging us to do this more. So you can subscribe and then share. Thank you so much.